go over your group quiz. Hopefully you talked with your friends and compared answers and checked with them. And I mean, if you didn't, let's figure it out right now. Obviously, if you can look at this video and see this first little section, and if you got all of the answers right, then skip forward to the next part of the video. Just check your answers, see if you got them all right. Totally fine with that. Maybe you don't need the explanation. I'm going to try and give an explanation as we go, and then if you have questions, then come see me in office hours. Yeah. All right, so first thing I did for number one is they gave you this the strikeout totals recorded by 16 pitchers, right? They gave you this data, and the first thing I did was list them out. I ranked them. I listed them in order from least to greatest. I'll put them all in order there. That's called ranking. And then for number one, I wanted you to make a distribution, a frequency distribution using classes of length 10, and we started you with 140. Not that it had to start at 140, but it just makes it easier for us to grade if we say, okay, start at 140 and then make class size length 10. And this means that all of your answers should be the exact same as mine, even though in reality, there's lots of different frequency distributions that you can make. But for this, we started you with 140, and so it should go to 149. That is a class length of 10. Use your fingers to count them out. Remember, it's 0 through 9 will give you 10. So it should be that. The other way I told you was you could go 140 plus 10 will bring you to 150 if you go down this first row. Adding 10 will bring you there. And then to end each class, then you just go one less than it. And then we write the, hopefully you did tallies first, and then the frequency of each of them should be that. Right? Then constructing a stem and leaf plot for the data. These were in hundreds, right? 3 decimal places. And so you'll put the 100 spot and the 10 spot, both of those in the stem, making sure to include, I know there weren't any 180s, but you include a class that, or a stem, I should say, that doesn't have anything. If there's any blank stems, you still include them. And then you list out each of the ones digits in order, right? No commas in between them. No commas in between. If there's commas, you're wrong. Don't put commas. And then you absolutely must write a key, or some books call it a legend. And that's just, you choose any one of these numbers. It doesn't matter. I chose the 153. That 15 with the slash line of 3 represents the number 153. You have to have the key for those. All right, then we did the histogram, which is just taking each of these guys and turning them into a bar graph, right, with horizontal rectangles, where the y-axis is your frequency, and the largest frequency was 4, and then each of the classes are the widths there. So keep in mind that these classes aren't on the tick marks, they're between the tick marks. It's the width of each of those rectangles. So you should have had that. And notice that to make it clean and neat, because if I wrote 140 to 149, it just wouldn't fit in that little line. And so I bumped it down to the bottom. And so there's your histogram. And then the frequency polygon, this is when each of the tick marks are the midpoint of each of the classes. So the midpoint between 140 and 149 was 144.5. And then each of the class sizes are 10, so adding 10 to each of those, and then I always am a double checker, so I'll double check 200 to 209. The midpoint of that would be 204.5. And you do dots for each of the frequencies, right? And then remember, this is the frequency polygon. To make it a polygon, it needs to be a closed shape. So we tie down the two ends by putting on the tick marks. We add more where this is the midpoint of the class that would have been right before the first class, and this is the midpoint of the class that would be right above the last class. So that's how we tie those down. All right, then let's put this all the way up. Here is answers to bottom half here. Making a box and whisker plot of the data. Remember this box, the middle of the box, this middle line is going to be your median. And I figured out, let me slide back up to I'll slide back up to the top to show you how did I find the median and the Q1 and Q3. So I went to my ranked data set here, and I counted in, and I found that the median landed right in between 174 and 175. So that's where I got a median of 174.5. And then you do include the 170 because the median is right in between those 2 points. So to find Q1, the lower quartile, you find the median from 147 to 174, and that lands right in between 159 and 165. Add those two numbers divided by 2, you'll get a Q1 of 162. And then since the median was in between these guys, you do count 175 and then all the way to 208, and you'll find that the median is in between 195 and 198. Add the two numbers together, divide by 2, and you'll get 196.5. So let me slide back up, and that's where, all right, so I just labeled some points on the x-axis. Notice the box and whisker plot is not on the number line, it's above it. And median was here at 174.5. Q1 was 162. Gave you this line here on the box. Q3 was 196.5, so that's over here. Create the box. Put dots for the extreme values. So the smallest value was 147, and the largest value was 208. I put dots there, and then I connected the whiskers. Okay, so that's the box and whisker plot for 6. P75, that means the 75th percentile, which means 0.75 times there were 16 total scores. So it's the 12th value is the 75th percentile. And so I went through and I counted back at my ranked data. I went through, and which one was the 12th value? Right there. 195 is the 12th value. And so that is P75. Q1, we figured out by, I showed you just above, right, where it was, you add the 2. It landed right in between 159 and 165, so add them up and divide by 2. The median landed between 174 and 175, so it was 174.5. The mode, which one occurred the most? 195 happened 3 times. So that was your mode. The mean is you add up all 16 values, right? Add 147 plus 153 plus 155. You should have had them add up to 2856, and then divide by there were 16 values, and so you get 178.5. And then the range is the largest value minus the smallest value, and that gave you 61. All right, so we had you answer all of those questions for that same set of data. For 12 and 13, we give you a new set of data. We want you to find the standard deviation and the variance. So these are the values you should have gotten. How did I get that? I used the table. I listed out each of these individual values. I figured out the mean. X bar means the mean. You find the mean by adding up all of these values, dividing by, there were 11 of them, so divide them by 11, and you get a mean of 15. So then in this middle column, I'm going to go x minus the mean. So 11 minus 15 gives you -4. That repeats. 13 minus 15 will give you -2. So you list all of those out, right? Subtracting this point from 15. And then you square it. When you square a negative, it's positive. So all of these values will always be positive. The sum of the differences is what that's called. So you'll square, square, square each of these guys. And then you add them all up, and you get 88. Okay? To get the variance first, variance, even though we ask it second, variance is what you actually find first. You take that sum and you divide it by, we didn't tell you, well, I treated it like 2, 4, 6, 8, 10, 11. Yeah, I treated it like it was the whole population. All right, so divided it by 11, and it's equal to 8, so that's where we get the variance. And then the standard deviation is the square root of the variance, which will give you 2.8284, and I went to 2 decimal places, so 2.83. All right, so let's show you the back side. Okay. Here are the answers. And again, if you look at this and you got them all right, then just skip on through to the bottom. But how did I find this? It says, assume that SAT scores are normally distributed. Okay, that means you can use the empirical rule with a mean of 500 and then approximately 68%. That number should sound familiar to you. 68% of the population scores between 400 and 600. So if 68% is here between 400 and 600, then we obviously know that's just 100 difference, right? What percent of the population scores above 600? So lots of ways of figuring it out. I figured out that, okay, 34% is between 500 and 600, right? Since the whole thing is 68, but it's symmetric. And then to the left of 500 is 50. So um, I did 50 plus 34 is 84. The other thing you could have done was go 50 minus 34 because I know all the way to the right is 50% of the data. So you could have done 50 minus 34 as well. In fact, that would have been faster, but whatever. All right, then average amount of time it takes Joe to drive to work is this guy. So that's his mean, right? And with a standard deviation of 5.12, find the z-score that corresponds to 22.5 minutes. So you take the actual time we're trying to figure out the z-score for, 22.5, minus the mean divided by the standard deviation, and you get negative 0.94335. So I rounded to 34. Find the probability that he drives to work in less than 25 minutes. So take 25 minus the mean divided by the distance. So you find the z-score. So now we're talking about probabilities. We're talking about the area under the curve. Z-score are these numbers, 0.46 is the z-score, right? But now we're trying to find the probability, and the probability is, the area under the curve. All right, so we get a z-score of negative 4.6, right? So I want, and the fact that he drives to work in less than 25 minutes means I want the area under the curve to the left of negative 0.46. But remember, the table that we gave you only has a positive 0.46, and it gives you the area to the right. So when I look in the table for a z-score of 0.46, I get an area of 0.6772. That's this shaded area here, but I actually if I want this shaded area to the left of 46, it'll be the same as the non-shaded area to the right of positive 0.46. The whole area under the curve adds up to 1. And so you just do 1 minus the area of this guy, which is how you get the 0.3228. Finding the indicated area under the curve. All right, so to the left of positive 1.49, that's a straight up look up 1.49 on your z table, and it'll give you 0.9319. So what I wanted in the table perfectly matched. To the right of negative 0.45 will be the same. To the right of the negative is the same as to the left of the positive. So all I had to do is look up to the right of the area under the curve to the left of 0.45, and that gave me the 0.6736. And then, now we get more complicated. We want between negative 1.2 and positive 2.35. So here's what I want. But the table, I have to look up a positive 1.2, and it's going to give me the area to the left of here. And I have to look up a positive 2.35, and it'll give me the area between here. And so there's probably a lot you may have done this differently. Totally fine if you got the same answer. What I did was I figured out what is this area to the left of negative 1.2, because 2.35 and all to the right would include this white area. But if I subtract out this white area, then it'll give me just the area in between here and here. So I found the area to the left of positive 1.2. I found what's this area to the right by doing 1 minus that, gives me 0.1151. So this white area here is the 0.1151, and it matches the white area to the left of here. And so the area all the way from 235 all the way to the left is 0.9906. Subtract from it this white area here, and I get 0.8755. Again, you may have done it in a different way, totally fine. For the scatter plot, I just put it in my calculator, put each of these values, and if you hit zoom stat, it'll put it in a nice, perfect little window, and you don't have to figure out what your window should be. I want to say, which one is zoom stat? Zoom 9. If you hit zoom and then number 9, it'll put your data scatter plot perfect in the window. And then when you did a regression equation, running that on the graphing calculator, I got y equals 47.50 minus 0.08x. And what's the correlation coefficient? It would be a negative 0.9742. And then predicting the miles per gallon when the engine size is 454. That's you just plugging in 454 into this equation, and you get 11.18 miles per gallon. All right. I hope you did well on the quiz. Make your corrections. You all have a fabulous day. Bye.